Hi, this is Bill Uren. What I'm about to present is performance engineering. The common uses of centering performance testing, it enables multiple concurrent uses, replacing serial testing with parallel testing. It also enables remote testing by anybody from anywhere at any time, eliminating the need to travel. It enables you to take advantage of the power of the web for supporting services such as web consulting, and online support. It also enables remote management from anywhere through a web server. I'll give you a brief overview of the performance center architecture. The PC server actually hosts a performance center web pages that enables you to design performance tests, configure monitors, reserve testing resources, run and monitor test runs, and analyze the test results. The controller is the manager of a performance test. The controller receives scripts, runtime settings, and a list of load generators to use. The controller issues instructions to the load generators, including the details about the scripts to run, number of users to run per script, and scheduler settings. At the conclusion of the test run, the controller collates the data. There is only one controller can be used per performance test. The load generator, it generates load by running virtual users. It dictates the manner in which they start and stop running. There can be any number of load generators for a given test. Then the data processor, it is used for analyzing and publishing the performance test results. While the PC host controls performance tests, generates load, and analyzes the data. Performance center hosts can be configured as controllers, load generators, or data processors. So enough to talk. I'm gonna do a performance testing demo. Now on this demo, we're gonna be running the service in AWS. We have four servers right now at hand, and we have ALM and Performance Center server sitting on one machine, and we have the application under test, which is AOS, Advantage Online Shopping, which is a web application. And we have two host machines, which is host 1 and host 2, where we're going to be running Vuegen scripts and uploading remotely the, the script to the Performance Center, ALM Performance Center. And now, as we go to the ALM Performance Center server, we can see that the ADM server is hosting ADM server computer name is hosting the performance center and ALM. If we go to the AOS machine, I've already switched on. Oops, let's return that. I've already switched on the application under test, which is the Advantage Online Shopping. Now, both the Advantage Online Shopping and the ALM Performance Center is accessible into our host machines, as you can see now. Okay, so this is host one, I mean host two machine, and this is host one machine. Okay. Now let's record the script and do a performance test. Let's launch Vuegen. Now at this recording, we're actually using virtual user generator version 12.63. So basically, this is a tool that we're gonna use to be able to record the transactions of the application on the test. Now, which is now the Vuegen is fully loaded. Let's make the IDE a bit bigger. So right now on performance engineering tools, these are the capabilities of Vuegen. Um, so it supports different protocols like TrueWeb and MQTT protocol as well. If we scroll down, it also supports three types of performance testing tools like Load Runner, Performance Center, what we're gonna use now, and Storm Runner Load, which is a SaaS version of performance engineering. So let's go to the left, click File, click New Script and Solution. Now, which virtual user generator is now loaded. On the right hand side, you could see the Vuegen and the protocols, and it supports some MQTT protocol and the TrueWeb protocol. As we scroll down, you can actually see the supported performance testing solutions. Load Runner, which is more of a project basis, Performance Center, which we are demoing right now, and the Storm Runner Load, which is a SaaS-based performance testing solution. So Vuegen actually supports all of this performance testing. Now let's create a new solution. File, new solution. Now these are all the protocols that are supported by Vuegen as we go along. Now we're gonna be using True Client Web as its protocol. Uh, Now True Client Web supports HTTP protocol, and since AOS the application on the test, so let's do AOS underscore performance test underscore demo as its name. Click create. Now, prior to recording, let's make sure that the version control is connected. So we do an ALM connection. Uh, so basically, now we're connected to the ADM server port 8080 as shown earlier, and we're actually connected to default project online shopping. Let's close, and as we go back, version control also supports Git. So if you're a fan of Git, doing pull, push, commit commands, it is actually fully supported on Vuegen. Now let's do a recording. So let's press exit here. Now let's type the URL. It's http uh, colon / adm dash aos ports 8080 / hash. So let's double check we have the correct one. Yep, adm / dash aos. Go back, press enter. Okay, let's do a record on the left, press the record button. As you can see, it actually recorded the navigation. Now let's choose laptops. Now let's scroll down. Let's choose HP Chromebook. Let's add to cart. Then press home. Now let's stop the recording. Okay. Now let's surround the steps into transactions. So imagine that you're actually testing an API endpoint, which is a service behind an application. So you could actually wrap up the dependency of the step on the front end UI and make it as a transaction. And we can actually see the performance of each step or each transaction um, of the application under test. So right now, let's wrap this up with navigate. That's okay. Now let's click again. Let's say end transaction, and not to navigate. Okay, so Let's do it again here. Start transaction. Let's say do a search. Press OK. So highlight. So let's include 2 steps into the transaction. Now let's create this add cart transaction. OK. Then wrap it up with ending the transaction. Add cart. Now um, let's surround this with transaction and navigate to home. To home. Press OK. Now let's save it. Rerun the script. As you can see, it repeats all the steps by transaction. Now transaction is actually repeated successfully. Now let's exit. You want to save it? Say yes. Now as you can see, the transaction is successfully recorded. So we actually recorded all the transactions without code, and that's how straightforward it is. Now let's save the script to our centralized repository. So let's file save script as. Now let's go to ALM plan test. Let's create our own folder. PC demo test. Go up. PC demo test and the left. Let's save it there. Runtime mode. So what we have just shown here is we will manage to save the script itself to a centralized repository. Now it's on a server. Now we have the capability to run the application on the test at any given point of time, anywhere we are. So let me show that how it's actually done. Now it's actually been saved successfully. Let's go to performance sensor. Let's log in my performance sensor. Let's use admin. Uh, Same. We're gonna be using the super secret password. Authenticate. Since we actually had the freedom to create a workspace, and right now we only have one, and a project itself, which is inside the workspace, AOS. So we have the capability here of having multiple workspaces and multiple projects within a single workspace, depending on the structure of our management approach on our implementation, from planning to implementation. So let's now log in. Now, upon login, let's go to the test. Now, on the left, upon going to the test, we can see the PC demo test that we created. And now, on the left, you could see a centralized view of all the scripts which has been created and can be run anytime and remotely. So let's choose the script that we actually created. Now let's go back and click the folder itself. Let's create a test plan. So let's put a test name, which is AOS underscore test. Let's press group, press OK. Now, which the test plan is actually created, let's assign a script to the test plan. And on the right hand side, let's go to subjects, PC demo test, and this is the script that we created. Now, upon successful navigation, we're going to specify the number of virtual users. Now, at this instance, we're going to be using 5. Now, as you can see, we're going to be, what we're trying to say here is we're going to be simulating 5 virtual users who's going to be accessing the application under test. Now, we're going to choose the load generator to determine the load which will be generated to the script. And right now we can actually choose a specific load generator to run the script itself. And as you can see, we have multiple load generators at this stage. And what we're trying to say here is one test can run one load generator at a given time. So from here, we could actually run multiple tests because we have multiple load generators right now. And at this instance, I'm going to be choosing ADM host _2. I'm going to press assign. Imagine that having multiple load generators, meaning it can be installed within the firewall or outside the firewall premises or outside the country itself, or different zoning or areas depending on your specifications for your application. And we can actually realistically foresee prior to deployment to production on what will be the performance of the application under test. Now we're going to assign the controller. Click this one. And at this instance, we have multiple controllers available as well. So we can actually choose either specific or auto match. And at right now, we could use auto match. Let's press OK. Now that we have the load generator and the controller assigned to the script, now we need to design the test scenario for the test execution. So at this given time, we're going to go to initialize and see it can be all V users running simultaneously, or a gradual increase in virtual users, or each virtual user just before it runs. At this instance, we're gonna choose gradually. Now we're being asked to assign a virtual user on every given time and on a wait period. So right now we're gonna have a virtual user every 1 minute, and the wait time we're gonna be having another virtual user in every 5 seconds. Now we scroll down. So we click the start all V users to initialize the virtual users. Now we're going to start all V users this time gradually. So it's going to be a gradual increase in V users instead of simultaneous. Now we're going to specify the number of virtual users per time period. It's going to be 1. And right here, it's going to be 1 virtual user every 15 seconds. As you can see the scheduled preview on the right. So in every 15 seconds, there's a 1 virtual user which will be added. So imagine if you have multiple users of thousands of millions of users, you can actually simulate here and configure the load and control it and assign it on a given time, a simulated time on the increase of the virtual users which is accessing the application. Now as we scroll down, so we click the duration, and under the duration we have options if we actually choose until completion, or for on a given time, or indefinitely until we wanted to stop an application on the test. So it depending on the test requirement. For right now, we're gonna be running it for, I would say, 2 minutes. Now when we scroll further, so this is the like exit strategy for the virtual users. As you can see right now, it's on simultaneous on the right, 5 virtual users at this given time. Now if we change it to gradual, it will be gradually um, um, switching off the application under test per virtual user. So right now we can actually have 1 virtual user on every 30 seconds, but I'm gonna make it show to like every 5 seconds. Okay, so you can see the change of this tip of the curve of the application under test. How is it going to behave of the users gradually leaving the application under test every 5 seconds. Now we're gonna save the test plan scenario. Now let's click run the test. Now in this window, we get to choose what test set we're gonna run it. Right here, we can actually create our own test set. So let's say AOS underscore test set. Press OK. Now let's choose the test set we're gonna run. So the essence here, we could actually run multiple test scripts on a single test set. But at this demo, we're gonna be running only one test script on this single test set. So let's press assign. Now this is the fully configured test. As you can see, now we're gonna run it. Now what we've been shown now here is the availability of the controller, and the load generator are actually displayed. And because we can actually use multiple tests at a given time, and you may have multiple performance test engineers and thousands of applications, and the load generator and controller may be on use at a given time. And now we can actually create a new time slot, or actually reserve a time slot. So right now, we're just gonna do a new time slot and press run. As you can see, the test is now running. As you can see, the load is still running. If we go to the transactions tab, we can see all the transactions which are running. And as it runs, we have a past, failed, stop, and success scenarios. And right now, 2 has already passed, and 1 has failed on the add cards. Now, if we go to the messages tab, we have a very detailed information of what's happening on each transaction. Now, on the left, we can actually see there's a warning, and there's a warning for CPU usage for the load has exceeded like 70%. So we have the error, and the add card button actually failed. So it actually tells us where the failure is actually coming from. So here at this time, we have the warning that the CPU usage has exceeded to 70%. And right here on the left, you can actually group by or filter by type. And right now, we could just see all the errors I would like to see. And just looking at all the errors, we could actually isolate and look at specifically what are the errors within the performance testing of the application under test. Now, the test result has been uh, provided to us. We can actually restart the test, open the results right now, or close it. But at this given instance, I'm going to show you the test results on our centralized repository. Let's close. Now, upon closing the dialog box, we will land into the scripts, and we can actually have a view on all the history of the test runs that we actually done. And now let's browse to the results of the performance test. Let's go to a host one right now, and let's launch the URL. Let's log in, and as you can see, we can actually access all the test scenarios, test results, anywhere we are. Now upon load, let's actually use the same user again. Let's admin. Uh, let's enter the super secret password, which I did not tell you earlier. And now we're on the same workspace, the same project. Let's log in. Now upon loading, as you can see on the left hand side, we have a dashboard. We could actually see results. We have release. We have requirements, and we have testing. So what I'm trying to show here is we have a complete SDLC and software testing lifecycle as well on in one graph, like a one-stop shop, doing release planning, requirements management, test planning, all in a single application. Look at the power of the collaboration, um, all tools and all solutions falling in one application. Now, clicking on the test module, we go to the test runs. So right here below, we can actually choose to download the raw results, actually view it on an HTML file. At this instance, we're going to view it on an HTML file. Click that. Now we can see the full results of the performance test, which actually run earlier. So now from here, upon choosing the HTML reports, we can actually see the project name, uh, which is Advantage Online Shopping, which we chose earlier, the test name, uh, the performance, how long it took, the number of virtual users, the throughput, the total throughput in bytes, the amount of throughput, the total hits, average hits per second. So below we have all the transactions that we created. At this time we actually created 3. So here we can actually see the minimum, the average, the maximum transactions, the standard deviation, if passed or failed or stopped. And we can actually see the HTTP response summary as well. Now, as we scroll down on the left, we can see the transaction response time for transaction. So this is the transaction response time against a percent of transactions. And upon hovering the graph itself, we can actually see more detail of the transaction itself. And if we scroll down, you can see 2 transactions which has passed. Now, if we go to the transaction summary, we can actually see which transaction has actually failed, which transaction actually has passed. And if we go down, we can see the response time against the ALM scenario as well. So this quite huge information that we can actually uh, digest here. Imagine thousands of transactions running, and we could actually see uh, the bottlenecks within each transaction because of the capability of our servers right now. We actually made the transaction smaller, so it's going to be easier to run. Otherwise, the server will crash. So so as we increase the capacity, then we could actually increase the virtual users and transaction as well. And on the left, we go to the throughput. So we can actually see the number of bytes per second and against the elapsed scenario time and throughput in MB. You can actually see the megabytes per second. So instead of transactions per second, as we shown earlier. Well, this is all for now. Thank you so much for watching my channel. This is Billy Ren. I hope you continue watching my video series.